everybody, welcome to this video tutorial. We're going to continue our study of linked lists in Java. We've already had a look at the node class, and we built a singly linked list where we were inserting nodes at the end of the list each time we inserted. You had the challenge of inserting a node at the start of the list. Did you figure that out? And in today's tutorial, we're going to look at how to insert into the middle of a singly linked list. So again, we're going to try and put a new node into a list. We're going to start from the root or the head of the list, and we're going to search for the insertion point. This is the insertion point. We were asking, is BMW less than Ferrari in the alphabet? Yes, it is. Is Chrysler less than Ferrari in the alphabet? Yes, it is. Is Honda less than Ferrari in the alphabet? No, it's not. So that's the stopping point for our search pointer. And then we're going to update the pointers. The new node will point to wherever we stopped. Oh, and the next pointer of the previous node also needs to be updated. So we will be tracking the previous node as we search for the insertion point. All right, let's get started. As in the last tutorial, we're going to have our external pointer as a global variable. Start with it set to null. So we're starting with an empty list, of course. So that's the situation there. And we're going to construct a new node, something like that. And we're going to try and insert it into the list. Today we're going to be implementing a method called insert in order, which takes a node object as a parameter. In fact, here it is. First thing we're going to ask ourselves is the list empty? Okay, so if root is null, we're just going to say, hey, root, you just point to the new node that we're trying to insert. Okay, and we can get out of the function because the job is done. However, if that's not true, it means that we have some information in the list. Could be something like that. So we need to set up our search pointer and assign it to whatever the external pointer is pointing at. So we create that situation here. Now then, this is where things get a little bit tricky. Let's see if we can visualize what's going on here. Do you remember we said, is BMW less than Ferrari in the alphabet? If it is, we're going to move the search pointer. But we also need to track the previous node, right? Then we're going to ask from our search pointer, is Chrysler less than a Ferrari? Yes, it is. So we just keep going. Is Honda less than Ferrari? No, it's not. So we found the insertion point. And we're going to update the new node's next pointer to point to whatever search pointer is pointing to. And we know the previous node because we're using this previous pointer to help us. So whatever previous pointer's next pointer is pointing to, we're going to point it to new node, right? So we set up our search pointer to point to root, but we also need to set up our previous pointer. And we're going to assign it, well, let's just go back to the beginning of this. At the beginning, previous pointer isn't really assigned to anything. We're just going to assign it to null. Okay. Now, while search pointers data when we compare it to the new node's data, if that comparison gives us a number which is less than 0, that means that this word comes before this word in the alphabet. Okay, that's the string class's compare to method. If you're not sure how that works, go and do a little bit of research. Now, if that's true, we want to do two things, don't we? We want to move the search pointer, and we also want to move previous pointer to be what search pointer was. So let's do that first. Previous pointer will be assigned the current value of search pointer, and search pointer will move forward. okay? Now, actually, we do need to make sure that in some conditions, this is just going to keep going, and search pointer eventually is going to reach null, right? If, for example, imagine if this word was Zulu, right? Eventually, we're going to slip out of the list, so we need to catch that condition. While search pointer doesn't equal null, and our comparison gives us a number less than 0. That's really what we're doing there, okay? Okay, so let's just get to our point. When we come out of the loop, this is going to be the situation, okay? So we're going to say, hey, new node, we're going to set your next pointer to be whatever search pointer is pointing to, right? This pointer here is going to point to Honda. And previous pointer, set next, this is going to point up to the new node. Okay, so that previous pointer's next is going to point up to there. We've just inserted a node into alphabetical order in a linked list of strings. There's one thing that we need to be careful of, though. Let's just come back down into the graphic here. What if this word is Zulu? If this word is Zulu, it means we didn't update any pointers. Previous pointer is still null, and search pointer is still pointing at the root. Nothing changed when we finished the loop. Okay? So if that was the case, we need to take the new node and put it at the beginning of the list, right? This has to go at the beginning of the list, Ferrari and then Zulu, to keep the alphabetical order. So new node's next pointer is going to point to search pointer, and root is going to point to the new node. That will insert this at the beginning of the list. But that only happens if we didn't move. So we're just going to check that when we come out of the while loop. How can we do this? If previous pointer is still null, it means that we didn't search for anything, because this new node has to go at the beginning of the list. Okay, so new node dot set next, it's going to be set to whatever root is pointing at, and root becomes new node. Okay. Whoops. Let's get my spelling right. So if previous pointer is still null, we're going to insert the new node at the beginning of the list, which is what that does. Else, we'll do these 2 lines of code. And that is how to insert a node containing a string into a linked list of strings in alphabetical order.